Assalamualaikum. Hi class, today we are going to continue with the second part of differential equation, where the variables of the differential equation are non-separable, means you cannot separate the two variables of the differential equation. Alright, so when you are not able to separate the two variables of the differential equation, you're going to solve the differential equation using integrating factors. Right, before we do our first example, we are going to review back the step-by-step in solving using integrating factors. Right, the first step is to identify our px and qx. And what are these px and qx? Right, px and qx we can take from here, where px is the function of x that is multiplied to y, and qx is the function of x where it is alone. Right, usually we put it on the right hand side. And step 2 is we need to find the integrating factors mu. Right, and this mu is equals to e power of integration of px dx. Right, so once we get the value of mu, we are going to put into the formula, and we are going to solve for y, where mu y equals to integration of mu multiplied by qx dx. Alright, so today we are going to try 3 examples. Alright, so I'm gonna separate these 3 examples into 3 videos so that you can see them separately. Right, so let's try the first one. Dy dx plus 3y equals to e power of negative 3x. Alright, so we have dy dx plus 3y equals to e minus 3x. Alright, remember our first step. First step is we need to identify our px and qx. Right, in this case, these are already in the basic form. Our equation is already in the basic form, where dy dx is alone, nothing is multiplied, or nothing is multiplied to dy dx, and the function of qx is on the right hand side. Right, so we can straight away take out 3, right, as our px, and qx equals to e negative 3x. Right, and the second step is to use px to get the integrating factor. Right, so our integrating factor is mu, and mu is equals to exponent of integration of px. Right, and our px is equals to 3. So 3 dx. Right, so we are going to integrate 3 with respect to x. So we are going to get e 3x. And now we have our value of mu, the integrating factor. Let's proceed with the last step, which is put everything inside the formula. Let's rewrite the formula first. Right, formula is mu y equals to integration of mu multiplied to qx dx. Alright, so what is our mu? Let's substitute mu equals to E3x, and QX equals to let's recall back, our QX is equals to E power of negative 3x. So exponent of negative 3x, and going to integrate with respect to x. So E3x, E negative 3x, we can simplify, and what do we get? Let's write here E3x minus 3x dx, which is, this gives you 0. So E power of 0 is equals to 1. So what we are going to do is we are going to integrate with respect to x, and this should give you 1. This integrate 1 with respect to x, you are going to get x plus c. And this is not our final answer yet, right? Remember, on the left hand side we still have mu, right? We want, on the left hand side is just y, right? So let's bring this down, right? What is mu? Mu is equals to E power of 3x and multiplied to y, and multiply both sides by E negative 3x. You're going to get this side as y equals to E negative 3x times x plus c, right? So that would be our final answer for this question.